Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from IIT JAM MS 2017, problem number 18. The problem says that let x1 equals to 1.1, x2 equals to 0.5, x3 equals to 1.4 and x4 equals to 1.2 be the observed values of a random sample of size 4 from a distribution with PDF f of x given theta is equals to e to the theta minus x if x is greater than equals theta and 0 otherwise. But theta is a real number, right? The parameter space is the entire set R. So then the maximum likelihood estimate of theta square is, so there are four options and we have to find the MLE of theta square. Remember, not the MLE of theta, the MLE of theta square. So let us deal with this problem in a general way. So this is the PDF, the population PDF, this one, e to the theta minus x, where x is greater than equals theta. And let x1 through xn be a random sample from above. That means the likelihood function L of theta given x curl is nothing but the joint PDF, right? Which is nothing but product ironing from 1 to n e to the theta minus xi, where each of the xi is greater than equals theta. Remember, this condition is very important. Each xi is greater than equals theta. x1, x2, and x up to xn. Each of them is greater than equals theta. Only then this is the likelihood function is equals to this, and zero otherwise. Zero otherwise, right? Now this thing can be written as nothing but e to the summation theta minus xi. Again, all xi's are greater than equals theta, and nothing but this, again, this is nothing but e to the n theta minus summation xi. Just this product is nothing but this product is actually getting distributed over here as a summation, right? Nothing but that. So e to the summation theta minus xi, nothing but, so this thing becomes e to the n theta minus summation xi. Now this, remember, this each of the xi's have to be greater than equals theta, which is basically means that the minimum of them is greater than equals theta, right? If all of the x1, x2 up to xn, if all of them are greater than or equals to theta, then the minimum of them is equals to theta. This is the equivalent condition. So that means theta is less than equals x order 1, the minimum of the smallest order statistic, right? So the likelihood function is this if theta is less than equals x order 1 and 0 otherwise, right? So the log likelihood, that means natural log of L is nothing but n theta minus summation xi. Again, theta is less than equals x order 1. Now the derivative with respect to theta is n, which is greater than equals which is greater than 0, right? Positive, it is positive. N is the sample size, it is positive. So that means the function is actually strictly increasing, right? Up to the function, this natural log of theta, this log likelihood increases on the interval minus infinity up to x order 1, right? It is increases. And obviously, therefore, the log likelihood and hence the likelihood function attains its maxima at theta hat is equals to x order 1. That means x order 1 is that value of theta at which the likelihood function attains its maximum value. Therefore, x order 1 is the MLE of theta. Now remember, we have actually found out the MLE of theta, not that of theta square, right? But we need to find the MLE of theta square, right? So how do we do that? See, by the invariance property of MLE, the MLE of theta square is actually x order 1 square. That means it just passes to the function. Since the MLE of theta is x order 1, the MLE of theta square is x order 1 square. Now here, now let's come back to the from the general problem to the particular problem. Here the sample size is 4 and the values have been given x1, x2, x3 and x4. Here the smallest value, that means x order 1, is actually 0.5. You can see that. This is 1.1, this is 0.5, this is 1.4 and this is 1.2. So the smallest is 0.5. So x order 1 here is actually 0.5, right? So here x order 1 is 0.5 and therefore the MLE of theta square is zero point 0.5 square, which is 0.25. Therefore 0.25 is the answer to this problem. That means option B, I think. Yeah, option B, right? So option B is the right answer, the right option to this problem. Very easy problem. Just a very simple basic application of maximum likelihood and the invariance property of MLE as well. So yeah, there you have it, the solution to this problem. So do like, share and subscribe to the channel for more exciting problems. See you till next time.